purpose of this video is to kind of recap what we went through on Tuesday with the baking soda example, but I'm going to focus here on the material portion of the transaction. So remember, we're using a standard costing system, and I'm just going to recap. I know we went through this in class, but the first transaction, actually the first 4 transactions, are to purchase the material. We purchase the material, we owe a vendor. We're buying them all on account, $1,200 plus $200 plus $100 plus $4,800. We owe our vendor $6,300. But what goes into raw material is not $6,300, and that's counterintuitive. What goes into raw material is the standard cost of those raw materials. So if you notice here, what I have is an equivalent of 10,000 bottles of raw material. The only one that doesn't seem obvious is the liquid. But the liquid, there is a 12 ounces per 1 bottle ratio. So if you divide 120,000 by 12, you get 10,000. So 10,000 bottles of raw material at 53 cents, that's my standard, goes into my raw material. Standard cost goes into raw material, but we have this problem where the accounting transactions don't match. So we're off by $1,000, and we said that's a purchase price variance at that point. We paid too much for the material when you compare it to standard. Okay, and then the next thing was we requisition all of the raw material. So all this raw material. So what happens is someone goes to the warehouse, says, I need all the material we have on the shelves, and it's $5,300. Okay, great. So we walk it out of the warehouse, we walk it on over to our manufacturing floor, and we put $5,300 into the manufacturing process, and that gets categorized as work in progress inventory. Okay, so that's requisitioning all the material. We run our machines, and that's the labor transactions we walked through in a different video, and then we are done. We're complete. We took all those materials, put them into the machines, and out the back end spot, there were 9,250 bottles. Not 10,000, but 9,250. So the logical question is, what happened to the 750? We have no idea. All we know is there are 9,250 that came out on the back end. So those 750, what we have to make an assumption here is that they're not still being filled or in process. They're gone. So maybe we broke the bottles. Maybe the bottles weren't there in the first place. Maybe the packages were mislabeled, and we only got 9,250 bottles and not 10,000. Regardless, what happens is we increase our finished goods, and remember, this standard costing system says now everything's moving through at a standard cost. My inventory accounts are at standard. So if I complete 9,250 bottles, and we're only going to deal with the material here, not the labor, then I should put into finished goods 53 cents for every bottle that's completed. So 92.50 times 53 cents. So that's how much material should show up in the finished goods inventory using a standard costing system. So we would pull it out of work in progress. But we have this problem now because my accounts don't match. And what we said is there's no more WIP. It's all gone. It's gone. You look out at the shop floor and there's nothing in the machines. They're all gone. So my work in progress at this point is overstated. And so the only logical explanation is we have a material efficiency variance. And that material efficiency variance is calculated using this formula right here. You take your actual material, and that's for each item, bottle, cap, label, liquid, actual material. Well, when that person went to the warehouse, they pulled out actually 10,000 bottles. They pulled out 10,000 caps because they pulled them out. They pulled out 10,000 labels, and they pulled out 120,000 ounces of liquid. Now, how much were they allowed to pull out? Well, they pulled it all out, so you could say they were allowed to pull it all out. That's not what I mean. What I mean is, based on how many they completed, 9,250, what should we have allowed them to pull out of inventory? Well, they should have only been allowed to pull out 9,250. They should have only been allowed to pull out 9,250 caps, labels, and bottles, because that's what the standard calls for. And they should have only pulled out 9,250 times 12 ounces. So I pulled my standard costs down from this bill of materials. 15 cents for the bottle, 1 penny for the cap, 1 penny for the label, and 3 pennies for the liquid. My formula here is simply taking this minus this times this. So this minus this times this gives us this. And I know it's an unfavorable variance because I'm pulling more material out of inventory than I'm actually allowed to pull out. So when I add up all those all those individual efficiency variances, I have a net unfavorable direct material efficiency variance of 397.50. And it is not coincidence that this 397.50, if you add all the credits up, now they match the debits. See how that works? So what happens is I'm dispositioning or pulling out of this work in progress inventory. Before I make this entry, my inventory is overstated, so I need to balance that by pulling this $3,997 out and saying, well, that's my direct materials efficiency variance. We know that a debit balance indicates an unfavorable variance. Debits equal credits. I don't touch finished goods. I'm just dealing with this scrap or whatever it is at this point in time and pulling it out, saying I have an unfavorable efficiency variance. So that is how we calculate the material efficiency variance. Feel free to go back and watch that as many times as you need, but that will be a concept that does show up on an exam.